bend in the detector. The reason this is important is that the bending in the foils would affect the gap between them and therefore the electric field that the electrons pass through. This would determine the gain throughout the detector. To measure this, lasers pass horizontally across the detector over various rows, and basically what we try to measure from this is that the more bending there is in a detector, the more variation there should be across the gain. So after we collect all this data, we apply some software corrections to fix any kind of rotation errors in the detector, and after applying these corrections, we're able to plot them and analyze them. So if you look here, we have the output from the planarity test of an India 006 detector and our gain test on the detector. So there's some interesting things to note here. In the planarity test, on the edges of the outside, it's a lower value and it increases as it goes towards the center. So this follows sort of a hill-shaped kind of effect. On this gain test here, we can see how the gain is the highest on the right side, as indicated by the blue and purple values. So we can see a slight correlation here. As the planarity increases and goes towards the center, the gain decreases. And if we take a look at the average values, that definitely is true. We ran this test on another detector, India 007. The planarity graph follows the same kind of shape, with rising towards the middle and going lower towards the outside. But the unique thing here is that the gain graph does not follow the same pattern. It is very high on the right side, but it doesn't get noticeably lower on the middle compared to the left. So in this case, there's no clear correlation that we can find, and it does not follow the same pattern as before. So when looking at this overall, we're going to need more statistics to establish a definitive correlation. When looking at the last one, we did find some sort of correlation, but we need to run more tests and on more detectors to acquire more data to analyze this further. Another thing that we can do for the future is apply this same process to the new GE21 detectors, which are going to come into development soon. They'll have an additional spacer in the center, and basically this will allow us to test the effectiveness of that by comparing planarity. So another test that we did separate from this is voltage versus gain uniformity. So when running these tests, there's one thing we need to be careful of. The readout chips on the detectors can sometimes be saturated by excess charge. This is usually at high voltage set points. So we need to run the tests on different set points to make sure that we have accurate data. Another reason that we do this is, if you look at this graph here, there's not necessarily a linear relation between the uniformity and the voltage point. It's a more complex relationship, so a better understanding is required. And to do this, we need to take more values at different voltage set points. So here's the results from our test on a GAN 002 detector. So if we look here, we did the gain test on this detector at 568, 610, and 660 voltage set point. The averages are increasing as we increase the voltage, and the standard deviation is roughly the same on 568 and 660, but is lower in the center. So from this, we can clearly establish the correlation that as the voltage increases, the gain does increase due to the stronger electric field. Another pattern that strangely emerges is that at the 568 and 660 voltage set points, we have a similar shaped graph here of the high gain on these sides, but the middle one does not share this kind of characteristics. So this is very surprising because you'd think it would apply across the range. So we need to investigate further whether this 610 high voltage point, whether it's an error in measurement or whether it's an actual real effect or phenomenon. So going forwards in the future, we need to run more tests like this and establish whether this is a real correlation or see and consistently measuring that. So overall, over the course of our work, we found that there could be a potential correlation between planarity or bending and the gain uniformity, but we need to run more tests to really find that out for sure. And also, we need to run more tests with the voltage set point and the gain to see whether there's also a correlation with that. But that definitely holds more promise. Yeah. Thank you for listening. Have a good day.
Any questions? Yeah.
Couple few slides here. Okay. More. It's here. example. But why don't you surprise that you don't have it on the left side that much? Like if you look on the most left picture, you have red
This one?
areas, exactly. Red areas on the left, on the right, and at the bottom. But when you look at the right picture, you will have high gain on the right side. But why not at the bottom? Like, why not in the left?
Right, so when we looked at these graphs, that definitely stood out. We were trying to look for any kind of correlation, and to do that, we took the average of each column here. So really, there isn't a strong correlation with this data we have right now between planarity and gain. So we're going to run more tests and see and find out what it is.
Okay.
Okay.